right? You go down to the table, you look for 0.75. Well, you can look here, okay, this is really, really small numbers up top here, right? For 1 degree and 2 degrees, like they're very small. So chances are we're just going to keep going down, down. We're looking for a relatively big one. Okay, well, it looks like right here, there's 0.75 there. Well, then you read over and you say, okay, well, what's the angle, right? Because remember, this column over here deals with the degrees, right? How many degrees is it? It's 37. So then you're able to say, okay, well, that must mean then, because I went and found the decimal number in the table, right, 0.75, theta must equal 37 degrees, because that's the angle that I read off of the table for this specific decimal number. Okay. Do we have any questions? Okay. Same thing down here. I want to just solve for angle A again. Okay. What you're going to find is this is like virtually the same process over and over again. Okay. And what I'm trying to get you to do is get in the habit of, because this is going to come into handy this afternoon, get in the habit of saying, okay, here's my angle A, because this is what I'm after. Okay, so that's where you're standing. It's asking you a question about that particular angle, right? So I'm going to stand right there. I'm going to say that's theta, right? I want you guys to get in the habit of, wherever you're standing, look across from you. You say this is opposite. Okay, then you're going to say, okay, well, what's beside me? Adjacent. That leaves one last side length, which we talked about yesterday. And you know what that is. That's the longest side length, right? What did we call the longest side length? Hypotenuse. Right? So you have 3 side lengths in a triangle. You're going to have opposite, you're going to have adjacent, and you're going to have hypotenuse. Okay? Now, for your purposes right now, you're going to use tangent to solve this triangle, or solve for angle A in this question, right? So solve for angle A, which we denoted was going to be the Greek letter theta. Tan theta is equal to opposite over adjacent, or rise over run, right? So you can say, okay, well, what's the opposite side length? 30 divided by 16. All right, let's get a decimal number. Tan theta equals, what's 30 divided by 16? 1.875. All right, is that your angle? I don't think so, because I don't have theta by itself. I have tan theta. I don't want the tan in there. The way to get rid of the tan is to go to your table and find this decimal number. So let's go to our table, find 1.875. That's a really big number this time, right? Like, we saw really, really small numbers up here, and then we saw some bigger numbers, right? And what you notice is, okay, I went all the way up to 1 here. You're like, okay, well, what happened at 1? I was at 45 degrees. And then you go to the second half, you're like, oh, look at the degrees start at 46 this time. So it's just a continuation of the table, right? It's as if it was sitting here, and it just kept going down. Then we had 46, 47, it just would have kept going, right? So you're like, okay, well, I need to go find 1.875. That's the number or ratio number that I'm trying to find, right? It's what happened when I divided opposite over adjacent, 1.875. So you're like, okay, let's go find that number. Well, it turns out you're not going to find exactly that number, but you're going to find something very, very close. I would say that's close enough. That's pretty much 1.88, right? So you're like, okay, I found the number. What's the angle that's corresponded with that number? Well, you just read over. You say, okay, oh, it's 62. That must mean that theta, in this question, theta must be 62 degrees. You're done. Okay? Does anybody have any questions on what I've done there? That's kind of like we reinforcing the concept from yesterday, okay, the question that we did. Okay, I might do one more like that. Okay. How about I do one question down here? Okay. I know, I'll do the first one. Okay, I'll do this one. Okay, this question here wants us to solve for all unknown angles, okay? Remember, the word solve in a triangle, if I were to draw a triangle, right, like the one up here, you're going to see that, okay, well, if it says solve, I have 3 side lengths, and I also have 3 angles, one here, one there, and one in the corner. I also have 3 angles. Okay, so if I had just said, or this question had just said, specifically just solve, just the word solve, you would be required to provide me with 6 pieces of information, right? Most of which would be provided to you. You may only be solving for 2 maybe 3, maybe. But all 6 pieces of information for a triangle, some of which would be provided to you, right? So you'd say, okay, I need to know all 3 side lengths and I need to know all 3 angles. That's what it means to solve a triangle, okay? Because this question has specifically only asked me for just the unknown angles, I'm kind of, well, what you're going to find here is that you're going to actually solve for all of them. Like you're going to know every piece of information in this triangle by finding the angles, right? Because you know all 3 side lengths already. Okay? So that's what this means, to solve for all the unknown angles, okay? So here's what we got to do. We got to set up. I'm going to move this because it's in the way. Okay? That's what we're after. 3 side lengths, 3 angles. So let's use what we just figured out. We'll say, okay, well, we can solve for angle A, right? We say, okay, angle A is equal to tan theta is equal to opposite. Where's the opposite side length? Standing at theta, I look opposite of me, 9 degrees. All right, so I always like writing this out, so I never make a mistake in where I put the numbers, right? So I know 9 is opposite, and that must make 12 adjacent. All right, so let's put that in, 9 over 12. So tan theta equals, what's 9 divided by 12? 0.75. And I see we're seeing this 0.75 come up a lot. It doesn't necessarily have to be 0.5. It could be anything, really. You saw all the different decimal numbers in this table. It could take on anything. Okay? It could take on any of these decimal numbers in this table under this column, the tangent column. Okay? Anywhere in this last column, it could take on anything. We're seeing 0.75 a lot come up. We know what 0.75 is, 37 degrees, okay? I suppose the interesting thing about this is that we're seeing 0.75, right? But the questions appear to be different. Like the triangles keep being different, right? And we saw why that might be yesterday. Is because it's a ratio, or it's the slope, right? It's the slope value of opposite and adjacent, or the rise over run, right? That means this line always has a slope value of like 0.75, or like up 3 over 4. Or another way to write that would be up 9 over 12, right? It's a slope. All we're doing is we're saying, well, how steep is that slope? Like our grade from yesterday with the roads, right? We're saying, how steep is it? We can actually, like, in our mind say, okay, it's 10 degrees down or up or whatever, right? That's what we're doing right now. We're trying to find the theta value. So we could say, okay, well, theta for angle A is going to be 37 degrees again, okay? When your slope is 0.75, your angle is 37. I don't expect you to know that, by the way. I didn't know that before we did 3 questions, okay? You're going to get different angles, right? Now, That's just one of the angles, right? Remember, there's 3 angles in a triangle, right? 3 angles. You have theta, which we just found, right? And some of you might say, okay, well, why can't I, and you can do this. We're going to say, okay, well, I need angle, well, I know what angle C is, right? It's 90, right? That's what the little square means in the corner. And we're like, okay, well, I know this one's 90 and this one's 37. That only leaves one more angle that I have to find, right? You say, well, how do I find that? Okay, and you're like, okay, angle B. So we can do the same thing, except this time I'm going to say, okay, instead of angle B, we could say, okay, well, we're going to use theta's sibling, phi. Right? And you're like, okay, well, I need to find phi. Right? You can see the difference between those two, right? You got a kind of a horizontal one versus a vertical kind of line through the 0, right? So that's just denoting 2 different angles, okay? So it turns out you could, if you wanted to, use this tangent process that we just finished doing. But there's something way, way easier, right? We know, yesterday I told you guys, we know all 3 side lengths, or sorry, all 3 angles in a triangle have to add to 180 degrees. That's just a rule, okay? So we know all 3 side lengths, I keep saying side lengths, all 3 angles okay, this is a rule. You need to know this. This comes in handy. Okay, knowing that. So if you know all 3 angles have to add to 180 degrees, you could say, okay, well, theta, I'm going to do like a little math statement. You don't need to make it this complicated all the time. You can just solve for it. Okay, I'm going to say, okay, well, I'm going to say theta plus 90, because it's the 90 in the corner, plus phi has to equal 180, right? I see 3 angles here. Now, you just told me what theta was. It's 37. So you could say, okay, well, 37 plus 90 plus phi is equal to 180. Right? So you're like, okay, well, this looks like kind of just a normal math statement now, right? So you can say, okay, well, how do I get this by itself? You say, okay, well, it's just 180 minus 37 minus 90 equals phi. You're like, okay, that's easy. Let's just type it in our calculator. 180 minus 90, well, that's 90, minus 37, 53 degrees. You have now told me what all 3 of those angles are, right? Does anybody have any questions? That's if you're solving for an angle, okay? You get this nice, when you solve for an angle, you get this nice ratio, you get a decimal, and then you go to your table and you find the degree number that is associated with that decimal number of 0.75. That's how this works, okay? That's how you get theta by itself in this question, okay? If we go down here, what if we end up in a situation like this? I no longer know all the side lengths, but specifically, I don't even know 2 of them, right? So if I go to write out tan, theta equals opposite over adjacent, you now have a problem. You're like, I don't know what to do. because I don't know what the side length is. So like when I look at this, I don't know opposite, right? Okay, I don't know what to do. Wow, yes you do. Because we always know, like if there's, there's three things here that you don't, or three pieces of information that you can plug into this equation. We talked about this yesterday too. We can plug in angles, we can plug in the opposite side length, and we can plug in the adjacent side length. What this equation allows us to do, or process, it allows us, if we know 2, we can find the third. Okay, so let's just plug in the stuff that we know. We've labeled everything, right? This is why I try to get you guys in the habit of, that's adjacent, and that is opposite. Okay, and always, 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 this is hypotenuse, the big one. Okay, if we do this now, you're going to thank me in a bit. Just labeling the triangle helps a lot. Okay, so we know some stuff in here. I can make a little list here. I'm like, okay, what's the angle that I'm working with? It's 67 degrees. All right, opposite is x. Okay, I don't know what opposite is. That's what I'm trying to find. But I do know adjacent, right? 14. So like, okay, it looks like I know 2 pieces of information. I can find the third is what I want to do. So let's just take our information and plug it into our equation that we have here. Okay, well, theta goes in where theta is. So you get tan, I'm going to go down here. Forget about this question. We go tan of 67, right? Because that's, I'm just filling in information. That was theta, right? And that's equal to, I don't know what opposite is, but they've said it's x. Okay, so let's plug in x. X over adjacent, over 14. All right, well, what happens now? We got this looks ugly, right? Never seen this before. You can say, okay, well, you're going to apply you're going to fall back on some of the math that you've done in the past, right? That we talked about, right? How do I get x by itself in this question? Well, I can multiply both sides by 14. There's nothing wrong with that. What's it look like now? Well, you get 14 multiplied by tan of 67 equals x. All right, great. X is by itself now. Right? You're like, okay, well, that's great. X is by itself, but I still don't have an answer. Well, this is again where you use the table, what we call the trig table, right? You're like, okay, well, how on earth am I going to multiply this 14 by this word tangent and this weird number there? It's not 14 times 67. Don't do that, right? But you're like, how do I do this? Well, remember, this is just like, the tangent is just a ratio, right? And specifically, we're trying to find out or figure out what the fraction or the decimal value would look like if the angle was 67. So you're like, okay, well, let's just go down. You've got the angle, right? 67. Where do we find angles on our trig table is what you want to know. Well, they're in the left column. So let's go look in the left column down here on the trig table. Okay, you're like, okay, well, where's 67? Well, 67 is bigger than 45, so I gotta go over to this side. 67, right here. So then you're going, okay, I know what my angle is, right? Because this is in degrees, it's angle. You're like, okay, it's right here. This is my spot. You're saying, okay, well, what is the decimal value? Well, it looks like there's a couple of different decimal values here, right? You're like, okay, well, which one do I pick? You pick the one that's under the tangent column, or the opposite over adjacent, right here. So you go, okay, I want this number right there. What is that number? 2.3559. So you take this number, that replaces all of this, 2.3559. It replaces this entire bracket. All of this turns into that decimal number. It's like 14 times that number equals x. What is x? X equals 14 times 2.3559. That, did I do that right? I did. Okay. So x equals, I don't know, you could call it 32. I didn't specify how many decimal places to round it to, so let's just go 32.98. That's what side length x, or opposite, is equal to. 32.98. Okay, this is problematic sometimes, but it's just a rule, right? If you see 67 degrees, where do I get degrees from on my table? The left side. And if I get it from the left side, the only other number that I can get is the decimal. So go get the decimal, and that replaces the entire piece. Tan 67 is this entire decimal, whatever the number is. And then you can just do the math on it, and that's it. Does anybody have any questions? I'm going to do one more. I can try to find I might do a couple more. All right, let's do this one. Okay. So, I want to solve for x. Obviously, okay? This is the thing that's missing. So, what do? You write out your, what we call the trig ratio, the tangent trig ratio. So you say, okay, well, tan of theta equals opposite over adjacent. This never changes. You're always just going to say, okay, tangent equals that, opposite over adjacent. And you're saying to yourself, okay, well, let's make a little list here. I like lists. Theta equals 37 degrees. That's the angle, right? And you're like, okay, well, let's label our triangle. I'm standing at 37. I look across. There's opposite. What's beside me? Adjacent. X. So opposite equals 30, and adjacent equals x. Okay, that's fine. Let's take this information and plug it into our equation. So we get tan of 37 degrees, you can just write 37, is equal to opposite 30 over x. Okay. Now you might all be thinking, oh, I don't know what's going on now, right? It's the same sort of thing now as before. You're like, I don't know what to do, right? There's nothing wrong with, at this stage, you're okay to do this. Get rid of this. Okay, how do we get rid of that? Because that looks ugly. There's like a word with a number, and I don't know how to solve for words, right? Like, okay, well, just get rid of it. How do we get rid of it? I'm given the angle. Where do I get angles from? My table. 37. Where's 37? 37's right here. What's the decimal value for 37? I don't know why we use 37 degrees so many times in this lesson. Oh, it's 0.77536. You can see how, like, even if I chose 40, it'd be a different number, right? But nonetheless, we chose 37 again. So we get, okay, there's the decimal number, 0.7536. Let's go up. 0.7536 replaces that entire piece. 0.7536. That's equal to 30 over x. Now, you guys have something that looks familiar. Like you should be able to solve that, right? It's a little harder than your normal solving. Like it's not as easy as this top one, where I just multiplied by 14 and solved it, right? Not as easy as that one, but it's doable. And we saw a couple of instances of this yesterday. When we were doing some stuff, when we were doing similar triangles, we saw this. Right. So let's just solve for x. How do we solve for x? Well, we could multiply both sides by x. That's fine. What happens when I do that? I get 0.7536. X is equal to 30. X still isn't by itself. So you're like, okay, well, how do I get x by itself? Divide both sides by 0.7536. Now these cancel with that. You're left with x equals 30 divided by 0.7536. X equals, what's the math? 30 divided by 0.7536. 39.8. How do I know that's right? It seems to fit the context of the question, right? Okay, your other side length was 30. It makes sense that your answer is not like 300 or something, right? Like that's crazy. It's 10 times bigger. Okay. Do we have any questions? I'm going to stop there just for the purposes of, I've done a lot of talking at you. Okay. What I want you guys to do, down here it's like, it gives you some instructions, and this is posted, so you guys have this. It gives you the instructions on how to do this, okay? And what I want you to do is go. You don't even necessarily, like, if you get the hang of it, you don't have to do all 6 questions. It's just say, do the first 3. Okay? Once you get those, go down. So these are solved. These are examples where you got to solve for theta, right? Which is the first part of the question, okay? So I do those 3. Don't worry about these ones down here. Just for the purposes of, like, I think you're going to have the idea by the time you get the first 3 done. You don't need to do 6 questions. Okay, then go down, do the first 3 questions here. You're going to use the same steps, except this time, what are you solving for? The side length instead. Okay? Anybody have any questions? Let's stop it there. I'll post that right now.